In the last class, we built the number system and 82 world, the foundation of everything in quantitative aptitude. Today, we take the next step and master two of the most useful tools in all of arithmetic, the highest common factor and the lowest common multiple, or HCF and LCM. These two ideas quietly power a huge range of exam questions and A200 towel, from bells ringing together to arranging things into equal groups, to problems on time and work you will meet later and A200 towel. And if you can recognize instantly which one a question needs, you save precious seconds under sectional pressure. We will also cover the basics of indices and surds, the language of powers and roots, which appear in simplification and in many number problems. None of this is hard once the ideas are clear. By the end, you will know exactly what HCF and LCM mean, how to find them quickly, and the telltale signs that tell you which one or what problem is really asking for. Let us build these tools. Here is our path for today. First, factors and multiples and 8212, the foundation. Second, the HCF and how to find it. Third, the LCM and how to find it. Fourth, the relationship between them and which to use. Fifth, the classic application problems. And sixth, the basics of indices and surds. Let us begin. Before HCF and LCM, we must be crystal clear on the two ideas they are built from and 8202. Factors and multiples and 802. Because confusing them is the single most common beginner mistake. A factor of a number is a number that divides it exactly, leaving no remainder. Take 12. It is divided exactly by 1, 2, 3, 4, 6, and 12. So those are the factors of 12. Factors are always less than or equal to the number itself, and every number has a limited, countable set of them. Think of factors as the building blocks that a number can be broken into. A multiple, by contrast, is what you get when you multiply a number by whole numbers in A2, A12. So the multiples of 12 are 12, 24, 36, 48, and on forever. Multiples are always greater than or equal to the number, and there are infinitely many of them. The simple way to hold the difference: factors divide into a number and are few, multiples come out of a number and are endless. There's one more idea we need: prime factorisation. Every number can be broken down into a product of prime numbers and 82-fold numbers divisible only by 1 and themselves. 12, for example, is 2 times 2 times 3. This breakdown is unique for every number, and it is the master key to finding both HCF and LCM quickly, as we will see in a moment. Learn to prime factorize fast, and the rest of this class becomes easy. So the takeaway: a factor divides a number exactly, and there are few of them. A multiple is the number times whole numbers, and there are infinitely many. And prime factorization and auto, breaking a number into its prime building blocks and auto, is the key tool for everything that follows. Now the first of our two tools, the highest common factor, the HCF, sometimes also called the greatest common divisor. The HCF of two or more numbers is the largest number that divides all of them exactly. Consider 12 and 18. The factors of 12 are 1, 2, 3, 4, 6, 12. The factors of 18 are 1, 2, 3, 6, 9, 18. The factors they share and A212. The common factors and A212 are 1, 2, 3, and 6, and the highest of these is 6. So the HCF of 12 and 18 is 6. It is, quite simply, the biggest number that goes exactly into every one of them. Listing all the factors works, but it is slow. The fast method uses prime factorization. Break each number into primes. 12 is 2 times 2 times 3, and 18 is 2 times 3 times 3. Now take only the prime factors common to both. At the lowest power they appear and 82 12. Here 1 2 and 1 3 and 82 12, and multiply them. 2 times 3 is 6. That is the HCF, found in seconds without listing anything. Hold on to the core idea, because it drives the word problems. The HCF is about the largest common size and A200 opaled. The biggest amount, group or measure that fits exactly into several quantities. Whenever a problem asks for the greatest, the largest, or the maximum something that divides given quantities evenly, your instinct should immediately jump to HCF. That single trigger an 84-fold, the word an 84-fold, largest an 84-fold, largest an 84-fold, or an 84-fold, maximum an 84-fold, maximum an 84-fold, will guide you correctly again and again. So the takeaway, the HCF is the largest number that divides all the given numbers exactly, found fast by multiplying the common prime factors at their lowest powers and A to 12, and it answers questions about the greatest or maximum size that fits evenly into several quantities. Now the second tool, the mirror image of the first, the lowest common multiple, the LCM. The LCM of two or more numbers is the smallest number that is a multiple of all of them and A212, the smallest number that each of them divides into exactly. Take 4 and 6. The multiples of 4 are 4, 8, 12, 16, 20. The multiples of 6 are 6, 12, 18, 24. The smallest multiple they share is 12. So the LCM of 4 and 6 is 12. It is the first common meeting point of their multiplication tables. Again, prime factorization gives the fast method. Break each number into primes. 4 is 2 times 2 and 6 is 2 times 3. Now take every prime that appears in any of the numbers, each at the highest power it reaches and 812. Here, 2 squared from the 4 and 3 from the 6 and 812, and multiply 4 times 3 is 12. Notice the neat contrast with HCF. For HCF, you take common primes at the lowest power. For LCM, you take all primes at the highest power. Two mirror rules from the same breakdown. And the core idea, which drives its word problems, is the opposite of HCF and 39 SSI. Number 1, HCM is about the smallest shared amount, and A2 are 12. The first point at which repeating cycles line up again. Whenever a problem involves events that repeat and asks when they will next happen together, or asks for the smallest quantity that fits several groupings exactly, that is an LCM problem. The triggered words are NA200 200 smallest, NA200 200, NA200 200 least, NA200 200, and A200 200 together again. So the takeaway, the LCM is the smallest number that all the given numbers divide into, found by multiplying every prime at its highest power and 822 power, and it answers questions about the smallest shared quantity or when repeating cycles next coincide. HCF and LCM are not just a pair of separate tricks and A212, they are deeply connected, and that connection is both a time saver and a favorite exam point. For any two numbers, there is a beautiful exact rule. The HCF of the two numbers multiplied by the LCM always equals the product of the two numbers themselves. In words, HCF times LCM equals the first number times the second number. Check it with 12 and 18. Their HCF is 6, their LCM is 36, and 6 times 36 is 216 82.1, which is exactly 12 times 18. It works every time, for any pair of numbers. This rule is genuinely useful, not just elegant. If an exam gives you two numbers and the HCF and asks for the LCM and 802 or gives the LCM and asks for a missing number and 802, you do not need to factorize anything. You just rearrange the formula. LCM equals the product of the numbers divided by the HCF. One quick division, and you have your answer while others are still listing factors. The deeper skill this class builds is the reflex of choosing correctly between the two under time pressure. Read the question and ask one thing. Is it asking for the largest thing that fits into several quantities, or the smallest thing that several quantities fit into? Largest and dividing means HCF. Smallest and repeating means LCM. Getting this choice right instantly is worth more marks than any calculation speed, because the wrong tool guarantees a wrong answer no matter how fast you compute. So the takeaway, HCF times LCM equals the product of the two numbers and A212, a formula that finds one instantly from the other and A212. And the real skill is the reflex to pick HCF for the largest dividing quantity and LCM for the smallest repeating one. Let us now see these tools in action on the exact word problems the exam loves, because recognizing the type is the holy game. Here is the classic LCM problem. 3 bells ring at intervals of 4, 6, and 8 seconds. If they ring together now, when will they next ring together? Each bell repeats on its own cycle, and they coincide at a common multiple of all 3 intervals and A212, and the first such moment is the lowest common multiple. The LCM of 4, 6, and 8 is 24, so the bells ring together again after 24 seconds. Any problem about repeating events meeting again and 812, bells, lights flashing, runners on a track and 812 is an LCM problem. Now the classic HCF problem. You have 3 ropes of length 12, 18, and 24 meters, and you must cut them all into equal pieces of the greatest possible length, with none left over. The piece length must divide all 3 lengths exactly, and you want the largest such length and A212, which is exactly the HCF. The HCF of 12, 18, and 24 is 6, so the longest equal piece is 6 meters. Problems about the largest tile, the maximum number of equal groups, or the greatest common measure are all HCF. Do you see the reliable pattern? The mathematics is the easy part. The exam is really testing whether you can read a problem and instantly name the tool. Repeating and coming together points to LCM. Dividing into the largest equal parts points to HCF. Train yourself to spot those signatures in the first reading of the question, and these become some of the fastest marks in the whole quant section. So the takeaway, bells or lights or runners meeting again, is always LCM. Cutting into the greatest equal pieces or forming the maximum equal groups is always HCF and AT200. And the skill that scores is reading the question and naming the right tool at once. Let us now turn to indices and A212, the mathematics of powers and A212, because they appear throughout simplification and number problems. And a few simple laws handle almost everything. An index or power is just a shorthand for repeated multiplication. 2 to the power 3 means 2 multiplied by itself 3 times, and A212 2 times 2 times 2, which is 8. The big number is called the base, and the small raised number is the index or exponent. This notation lets us write and handle very large repeated products compactly, which is why it appears everywhere in quant. 3 simple laws do most of the work. First, when you multiply powers of the same base, you add the indices, and A212, 2 to the power 3 times 2 to the power 2 is 2 to the power 5. Second, when you divide powers of the same base, you subtract the indices. And third, when you raise a power to another power, you multiply the indices. Add when multiplying, subtract when dividing, multiply when powering, and A212, 3 clean rules. 2 special cases are worth memorizing because they trip people up. Any non-zero number raised to the power 0 equals 1 and A212 not 0 but 1. And a negative index means a reciprocal, and Arthur-Wolff 2 to the power minus 1 is 1/2. These 2 facts appear constantly in simplification problems, and knowing them instantly prevents silly errors. Beyond these, the 3 laws cover almost every index question the banking exam will ask. So, the takeaway, an index is repeated multiplication with a base and an exponent. The 3 core laws are add the indices when multiplying, subtract when dividing, and multiply when raising a power to a power. And remember that anything to the power 0 is 1, and a negative index means a reciprocal. Finally, Surds and A200 tool. The world of roots and A200 tool, which are the natural companion of indices and appear in simplification and number-based questions. A surd is simply a root that cannot be simplified to a neat whole number, and A212, most commonly a square root. The square root of 9 is 3, a tidy whole number, so it is not a surd. But the square root of 2 or the square root of 5 cannot be written as any exact fraction or whole number. Those irrational roots are what we call surds. They are perfectly valid numbers, they just do not come out evenly. The first skill is simplifying a surd by pulling out any perfect square factor hidden inside it. Take the square root of 12. Since 12 is 4 times 3 and 4 is a perfect square, the square root of 12 equals the square root of 4 times the square root of 3, which is 2 times the square root of 3. We have simplified a messy root into a cleaner form, spotting the perfect square factor and 8 to 112, 4, 9, 16, 25, and 8 to 112. Inside a root is the key move, and it makes surds far easier to compare and combine. The second skill is rationalizing the denominator and 8 to 112, removing a surd from the bottom of a fraction, because a root in the denominator is considered untidy and hard to work with. If you have 1 divided by the square root of 2, you multiply both the top and the bottom by the square root of 2. The bottom becomes 2, a whole number, and the fraction becomes a square root of 2 over 2. You have not changed the value, only made it neat and easier to handle. For the banking exam, simplifying roots and rationalizing simple fractions is all the surd skill you typically need. So the takeaway, a surd is a root that does not simplify to a whole number, simplified by pulling out perfect square factors, and rationalize a fraction by multiplying top and bottom to clear the root from the denominator and 81 to half, the two surd skills the exam expects. Let us close by turning all of this into a smart exam approach. Because in the banking prelims, speed and correct recognition are everything. First and most important, recognition before calculation. The moment you read an HCF or LCM word problem, your first job is not to compute but to name the tool and I to 1. Largest dividing quantity means HCF, smallest repeating quantity means LCM. Getting that choice right in the first 2 seconds is worth more than any speed, because the fastest calculation with the wrong tool still earns 0. Train the recognition, reflex first, and the arithmetic second. Second, lean on prime factorization and the product rule. Prime factorizing quickly gives you both HCF and LCM without slow listing, and the HCF times LCM equals product formula often hands you an answer in a single division. These shortcuts are exactly what separate a 35-second solution from a 2-minute struggle, and in a time section, those saved seconds compound across the whole paper. Third, drill the small facts that cause silly errors, the index loss, anything to the power 0 is 1, negative indices as reciprocals, and the perfect squares up to at least 25, so you can simplify surds on sight. These are not deep ideas, but under pressure, they are exactly where marks leak away. A few minutes of daily practice locks them in permanently. And remember, these tools return later an A212, in time and work, in pipes and cisterns, an A212, so mastering them now pays repeatedly. So the takeaway? Recognize the tool before you calculate, use prime factorization and the product formula for speed, and drill the index laws, the power 0 and negative index facts, and the perfect squares and 82 hundo. And these fundamentals will earn you fast, reliable marks now and throughout quant. Let us gather the whole class in one breath. Factors divide a number and are few. Multiples come out of it and are endless. Prime factorization is the master key. The HCF is the largest number that divides all the given numbers and A to fall. Take common primes at the lowest power. LCM is the smallest number. They all divide into any A2 hantu. Take all primes at the highest power. HCF times LCM equals the product of the two numbers and 81 to ball, and choose HCF for the largest dividing, LCM for the smallest repeating. Bells and lights meeting again are LCM. Cutting into greatest equal pieces is HCF. Indices are repeated multiplication with 3 core laws. Surds are roots you simplify by pulling out perfect squares and rationalizing. Next class, an A2 perv percentage, the single most useful tool in all of quantitative aptitude, one idea at a time. So that is HCF